So, what we're going to do is rearrange this a little bit to see how we could get something in terms of c, because c is our fixed constant here. So if we could describe things in terms of c, it might help us to reveal something between these two reference frames. So what we're going to start by doing is moving all the c terms on the same side. So I'm going to move this guy over here, and I'm actually going to subtract the delta x prime squared over there. And this will actually let us write something like delta x squared minus delta x prime squared is equal to that term over there, c delta t squared minus c delta t prime squared. Next thing I'm going to do is factor out a c from that. If we were to factor out the c, we would have a c times the quantity of delta t squared minus delta t prime squared. C times the quantity of delta t squared minus delta t prime squared. And actually, I'm going to go ahead and divide through by that delta t term. And I'm going to flip sides here just so we have the c on this side. So we get c equals that delta x squared minus delta x prime squared divided by the t delta t squared minus delta t prime squared. Now, cool, this tells us c in terms of a bunch of delta x's and delta t's. Where do we get v from? Where do we fit that in? Well, what we're going to do is realize that we can actually do something quite interesting here. We can factor out of this whole thing by factoring out of the bottom a delta. Let me look in my notes here to make sure I don't mess this up. Yes, that's right. Delta t squared, delta t prime squared. If we were to factor that out from the bottom, what would that look like? Let me check my notes here, make sure I'm not messing up. Right, if we were to factor that out from the bottom there, we could think about what that would actually be equal to. Delta x squared minus delta x prime squared. I should actually split that off because we haven't done that yet. We want to factor that term out of there. Same thing. So we can think about that. Well, delta t squared divided by delta t squared is 1. But then delta t squared divided by, and then 1, so that gives us 1. My apologies, I'm a little stuttery here, but bear with me here. 1, and then we have 1, but then we don't have anything to cancel out the over delta t prime squared. So we get 1 over delta t prime squared. And then the same thing is true over here. Well, minus delta t prime squared divided by delta t prime squared is 1, but we don't have anything to cancel out the delta t squared. So it's just over delta t squared. And that's what that factored out. Now, we can actually take that we factored out and multiply it through by the top. That is delta x squared times 1 over delta t squared, delta t prime squared, minus delta x prime squared over yada yada yada. And what that actually equals is, so if I just write it there, delta t squared, delta t prime squared, that actually equals, and I'm going to send that through the top, that is equal to, well, delta x squared divided by delta t squared is v squared, but then nothing to cancel out the delta t prime squared, so we get delta t prime squared, minus delta x prime squared divided by delta t prime squared is v prime squared, but nothing to cancel out the delta t squared, so I get delta t squared. And all of that is still over 1 over delta, oh boy, 1 over delta t prime squared minus 1 over delta t squared. Now this is equal to c. C squared. I forgot that. So, just from the postulate of special relativity, we arrived at this form of writing, c squared. Now, this is kind of crazy, and we can't really do anything with this, it seems, with the math. So let's figure out something to do to make this model simple. Oh, what if we look at the case where v prime is equal to negative v? So let's go ahead and do that. We're going to look at the case that v prime is equal to negative v. If we do that, we get that c squared is equal to v squared over delta t prime squared minus, now v prime squared, well, v prime squared is negative v, but negative v squared is just v. So we get v squared over delta t squared. Now notice we didn't just choose v prime equals v, because that would just imply that we're in the same reference frame with respect to velocity, and that would make this whole thing trivial. So we've assumed that they're opposites. Now, we have all that still over 1 over delta t prime squared minus 1 over delta t squared. But now we can actually factor out a v from that side. V squared times, on the top we'll have 1 over delta t prime squared minus 1 over delta t squared. And that's all over 1 over delta t prime squared minus 1 over delta t squared. But that stuff cancels out and goes to 1. So we get c squared equals v squared, which means v would have to be equal to c in this case. In other words, v prime is equal to negative v equals negative c. So that means that this case that we've looked at, even though it simplified the maths down, which it does in the special, in the derivation, implies something else. It implies that we must be looking at something with velocity c, and this is actually something often overlooked in those derivations. Now, I'm not going to go into the implications of this because that's more of a complex subject that we need more of a background in special relativity to begin with, but if you do know about special relativistic mechanics, you can already probably start to see where stuff gets a little messy when you've made this assumption. And I encourage you to go ahead and look at it yourself and try to figure that out. If you enjoyed this video, go ahead and please give it a like and consider subscribing for the next one's going to be coming soon, and that's when I will be doing an overhauled look at special relativity. This has been a physics video by Dr. Beanut, and you have yourselves a glorious rest of your day.